Hi, this is Tony, owner of Hurricane Wind Power here, and today what I want to do for you is to try to attempt to do a full discharge test to show you the watt-hour capacity on our new Hurricane LiFePO4 battery. This was put together here, and I think that everybody with any common sense knows that these cells do not come from the United States, so I'm not going to stick a big old Virginia sticker on here and act like, this is a made in America product like some of the people on the market that are doing. Respect the work that we do. I mean, this thing's got a really nice battery management system in it, and there's some work to putting these things together and getting a quality product. I honestly don't know what we'll come up with today, and I will run the camera as long as I can, but this would be a long, boring video. Let me show you what I've got here. I've just got a 12 volt 600 water heating element that we have attached to our battery. I have not put ring terminals on here, so this is initial testing. I could have put breakers on here. This is something I wanted to kind of do fast. And, I've just got these up here, so if something goes bad, I can get this taken apart quickly. What I'm going to attempt to do today is use our WattsView software over here and demonstrate how many watt hours we can get out of our Hurricane battery. And, I don't know where we'll end up at, but I'm going to go ahead and connect the negative terminal. You guys have seen us use the WattsView software, so you can see, we've got the voltage probes here. We have the positive going through the amp probe that goes to the computer. And then when I complete this connection, we should see this thing discharging in some hot water. Now below, what we have down here would be, let me get this out of the way. I'm telling you guys, I've spent so much time helping people protect themselves with energy security in the last months. We haven't made any company COVID statements. We've just been straight up helping people secure themselves with their energy needs. So we're going to go ahead and get this out of my pocket so I'm not dragging this around and empty some things out. I'm going to get to work here and show you guys what we can do. Hopefully this ends up successful. Maybe not. I'm hoping for over 1,000 watt hours on this setup. So we are going to submerge the electroplated part of the battery into the water, leave the terminals out. You could submerge it. It's only 12 volts. However, just not really a good idea. You'll get some rusting on the backside of the terminals. That's the nature of the beast. So let me hook this up here and see where we end up. And maybe I'll put on some sunglasses before we hook this thing up. There's a ton of energy density in these batteries. I've run this a few times, and we've done a few builds, and I think we're to where we need to be at, and we shall see. So that's our 600 watt element right now. This guy is putting out, I'm trying to get a good connection on that. Boy, if I had time, we should have just wired this thing up with a breaker, but I want to make sure that doesn't heat up. I want to get this guy out of the water to the extent possible. Okay. All right. Now, we're heating up. See what we've got here. Water is at 80.7. Come on around here and watch how this thing is climbing already. We're at 82 and 82.2. The watt hours on this thing are moving on up. It's under a pretty heavy load. So we're going to let this thing run and talk about some other things. So, you know, I think I covered in the DC water heating elements before. Why do we use the DC water heating elements? I think before I get into that, I probably want to find something and cover this up, because we're going to end up losing heat out of the top of this. And I think I'm just going to let that submerge in there. It'll be all right, I do believe. We come back, and I think I'm going to use an axial flux stator core. Then we can still shoot the temperature through there. Maybe stick a little cardboard. See where we're at on the temperature on this thing. This guy. Not much movement there. Watt hours keep on going. We'll top this thing on off. We could have insulated this thing and did a much better job. Primarily, heating water is just the load that I chose today. This is really more about wanting to see what we could do with our battery is in terms of the watt hour production. This thing does a real nice job with the battery management system of charging out to about 13.6, and you can see when it gets hit with that load, it comes on down. It's holding really good. That's a nice 50 amp load. Now just think about this in the context of you had one of your normal sealed AGM batteries or one of your lead acid batteries, and you're sitting here just straight up pulling 50 amps out of it, and think about how long that would last while we film this. Before I get this battery and put it on the market, we're gonna be damn competitive, or we're gonna exceed the power output of what the big boy brand names, say that they'll do. And I think we're going to come at you with a price point on the market that is something that I think you'll like. Some of these other things on the table. Now, when you get into the DC water heating, why do we use the DC water heating elements instead of the AC? We get into, when we do the wind and solar systems, my camera person informed me I don't have my mic. You guys told me about that out there in YouTube land, and I've been working on that, and I'm trying to do better for you. But, nonetheless, with these off-grid systems, a lot of the time we see folks that, you get that morning sun and they're not up, and before you know it, their batteries are full before, and things are just sitting afloat. I hate seeing solar systems, and, one of our wind turbine videos that we've shown, and I think in that wind turbine video, we've begun, shown the capabilities of our equipment. And, I see people make comments about wind turbines and competitors, and, you know, for me, there is really no competitor. I mean, you know, to me, I'm just like wondering which one of those guys is going to come in second. You know, there really isn't a competition. I would be more than proud to back that statement up. You know, those guys down at the National Research Energy Laboratory have towers and they certify wind turbines. So, what's the date? What's the date? What's the date today? Yeah, I'm June 20th, whatever. You know, anything on the market, I would be happy to go head to head with on a poll at the National Research Energy Laboratory. And, you know, that's why people drag race cars. You know, they want to see, you know, all this nonsense. And, you know, not all of them, but you guys got to understand, I'm not hating on those people, but a lot of people are showing ridiculous things. And, you know, when you see these affiliate links and things, you just got to understand that they get $20 every time you click and buy a little toy wind turbine. You know, we run into some things. Our stuff, it's big. It weighs 60 pounds. It is what it is. But, you know, we've backed up the power ratings that we've shown, and we've shown continuous power ratings. So, you know, the wind turbines and the solar systems, you know, we're showing these productions. And when you put these batteries together, there's only so much battery capacity that, you know, you can get out of, you know, as far as charge rate. So you get your wind and you get your solar, and, you know, you've got your charge rate. You know, in a lot of instances, we're having to dial these things back on the programmable controllers because, I mean, let's face it, batteries are just expensive. While I've said a lot of things about these type of controllers, yeah, I finally built one. It's got a ground wire on it. You know, something like this we can set up, you know, to when your voltage gets to a certain point, you know, so you don't go into float, you can divert that over to your DC water heating element. And, you know, yeah, that's a good use of the load control. We found several uses of the load control. I still don't really like it in terms of a charge controller. I don't have one sitting on the table, but, I mean, you know, the Xantrex line, it's still got that potentiometer on it, and it still does bulk float and absorb. So, I mean, you know, when you get into charging these batteries, though, you know, the lithium does not have an absorb cycle to it. So, I mean, theoretically, that puts this little guy into play. We could have done this. We could have done this backwards because this comes in and then this would come over. You know, just whatever you got in mind. You know, these nice backer boards that we have for these, we're going to put these up for sale. So, you know, whatever you want to do, we can help you design it. And there are just, the applications are endless. So, I mean, you know, what you have there is you have a normally open circuit that when it gets to a certain voltage, it closes and it allows power to pass through. Now, this relay is rated at 100 amps. On a consistent level, I probably wouldn't run more than about 60. If you're diverting more than about 60 amps, I mean, you can just, these control modules, you can be running parallel, and you can put as many of these SSR relays as you want to on there. So, you know, that's something, it's not new. We've been doing it. It's just, you know, something that's application specific, that we do a lot of specialty work for people, designing systems that, you know, frankly, a lot of the people, you know, want their privacy, and we respect that, you know, prepper, off-grid, and, you know, a lot of people with common sense don't want to go on YouTube and show everybody where their stuff is. So, you know, I'm down with that. I respect that. And I mean, that's just common sense. But you can see the big heavy relay up here. We got the big heavy contactor wire. You know, this thing will carry your heavy current. We've got this guy down here, you know, these are your control wires. This will carry a 4-gauge wire. So, I mean, you know, we're covered, you know, as far as carrying the current. Now, when we get into, I just don't like mechanical relays. I've seen too much stuff where stuff gets stuck open and stuck closed, and it will either ruin your battery one way or other. Now, you know, you have to continue with this. I'm going to go into a demonstration another time where we get into showing how you need to match your diversion loads correctly with what you're doing, you know, when I say what you're doing, I mean your batteries. If you put too much diversion load and this thing opens up, it's just going to knock the hell out of your battery real quick. Not good for the battery, but, you know, everything is a tool and it has a time and place. So, you know, we've got these in 12, 24, and 48 volts. So throw that out there. So let's see, I'm checking in here. This thing has not moved off of 12.4 volts. I've been running my mouth for quite a while now. The element, our 12 volt element, you know, it's running over 600 watts, which is what it's supposed to do. So I'm gonna peek in a moment and see if we're getting any water heated up. And if you check that here, we're coming on up 92.8. So we will close this back. Ghetto water heating at experiment number 1. And see how it goes. You know, I know some of you guys get into arguments on other videos and talk about lead acid and, you know, batteries plus versus. I really like some of the telecom batteries. I really do. And I mean, if you follow some of the design work and installs that I've done, you see some of the big, heavy form factor telecom type batteries that we sell. And that really gets into cycle life. Now, this is that square. It's not the cylindrical. This is the square prismatic cell. A lot of energy density in this thing. I'll reach over a minute and, you know, when you're doing this kind of thing, I imagine these terminals, a little bit of heat, 75 on that side, a little bit hotter over here. I didn't get a great connection on there, but you know, energy density for that little package, that thing only weighs 35 pounds. And it has not moved off of 12.4 since we've been sitting there. And, you know, it's just clocking in the watt hours. So the volts actually went up to 12.5. So, I mean, so far this thing is running pretty sturdy and pretty stout. I don't actually think, you know, this is our Watts View probe, and, you know, it just uses the volts times amps equals watts. I really don't think that, you know, with one of the watt meters, I don't believe you could do this kind of testing with. And, you know, we're going to lose a ton of heat out the sides, and, you know, this nice stator core, I mean, that thing's got a lot of copper and density to it, so maybe we'll keep some of the heat from coming out of the top, but that thing's putting out more power than it did the last time we looked at it. So, all the things that are going on in the world. You know, when you think about your your different type of solar generators that are out there on the market. Your I can't think of the guys that make the real expensive cups, the Yetis, and the things that I get annoyed at because people spend $2,000 or $3,000 on what, to me is like $400 worth of equipment. People spend tons of money upgrading batteries with those, whereas, if you think about the power that you could get out of one of these things, it's completely ridiculous. It's not even close. I'm talking a bunch of crap right now. We might not make 1,000. We might make more. We might make less. I really don't know. I just know that I've seen what's in the other people's battery, and I've seen what we've put in our battery, and knowing what I know about electronics, I think we're sitting pretty good. There's always testing, there might be something I've missed, so we'll have to wait and see, but, so far so good. When you get into just working around with these electronics and things like that, some of the things that you see on the table, just want to reinforce. When we do any install work, this thermometer that I'm checking things with, you should go over every wire, every terminal, every breaker, everything that you've done in your system. If you have something loose and it arcs or the wire's too small, you're going to find it. When you get those MC4 connectors that have a current to it that you didn't know, maybe you didn't feel like it seated good. When everything's out running, I always like to go over things with the we got a good thermometer here. Obviously the voltmeter, and the continuity test. If you're going to get into this, being able to test the continuity, to know if things are working correctly or not. If you have a complete connection, that's important. Being able to test the resistance, that's important. So, just from our side of things, when I'm working with people, if you don't have those tools, that's difficult. And one of the other things, when we're talking about these batteries is system sizing and how many batteries do we need. So this thing, if you pull 200 amps out of this thing, out of this battery with a battery management system, it would pull that surge. But we're gonna modestly call this 100 amps. That gives you, if you got a good 1,000-watt pure sine wave inverter, that will do a good amount of things for you for an extended period of time. This will absorb a lot of power, and what we're trying to do here in a bad situation is get you through the night, right? So your houses use a lot of power. Everything, heat and water uses a lot of power, but the cost per cycle, this battery is rated at 5,000 cycles. So if you do the math on that, 365 in a year, you take this thing, a lot of folks say you can take the lithium down to 100, and you can take this thing down to 100. If you treat it kind of nice and don't discharge it more than 80%, you're still going to get that deal where you see increased cycle life over time. Some of the other batteries that we use, the form-factored telecom type batteries, those, 3,000 cycles. So I mean, if you use that, a lot of the stuff that we're using in our designs, you're looking at 6 to 10 years on the battery storage. So when we get into this thing, when I got into renewables, a lot of folks come to me and they start by wanting to buy a wind turbine, and they're not really thinking about the entire system. So I mean, I've kind of gone through this in my videos before, but this is a typical call that we have people that want to buy a wind turbine and they don't really know what voltage and they don't know what they're doing. So obviously today we're showing batteries. Now, for the customers that are calling in and they just want to put some solar panels on their home and decrease their power bill, you're not going to buy batteries for that, right? Batteries are expensive. At the end of the day, all those systems are going to be direct and, to the inverter. Hopefully you've got a power company that has a decent buyback rate, and those vary. Some states have laws where they have to do a 1-to-1 buyback rate. That's good for you. But, that being said, other folks call in and they want to be completely off the grid, or they have a piece of property where the power line doesn't go. And that's where you have to start looking at energy storage. And really that's, we do the other type of systems too. We do everything here, but we kind of have focused and specialized on off-grid battery-based systems. And I really like the ones what we call grid tie interactive. So we can set up, when we have some battery storage in a system, you can, like right now it's cloudy outside. It was sunny earlier. You can save up some power when it's sunny or the wind's blowing, and then you can use that power rather than dip it into the grid when you don't have optimal circumstances for wind and solar. So in that regard, the batteries kind of act like a capacitor in the system. So, you get that. A lot of people don't look at that aspect of the payback, buying the batteries. Even if you buy a small set, if your power, if PG&E in California turns off your power and you got 12,000 watts of solar on your roof and you don't have any battery storage, with most systems, you don't have any power. It is what it is. At least with the grid tie interactive systems. And I mean, on the other end, on the systems that I like being off the grid and I love being self-sufficient, but if you got 8,000 watts of solar and your batteries are charged up, I despise walking by one of those off-grid systems we've done and looking at the controller and you see that it's in float. For me, home-based, if you have an electrical line ran in, the grid tie interactive systems, like some of the Outbacks, the smaller ones, 3524, been around for years, the 3648 and the Radians and the Snyder Electric Connex, the 6848, you get the best of both worlds. You can be off-grid, or you can, they've got a grid zero mode, some of them do, and then some of those you can set up, and after your batteries are charged back to a certain point, it sells back to the grid. So, that's, to me, and I like that because when the power goes off, you have what's known as a critical loads panel. In your critical loads panel, those circuits that your CPAP machine or your refrigerator, or if you've got something split phase, it's 240. If you got a well pump, a lot of people put that on their critical loads panel. and you know, you're still up and running, and you got that safety and security. And I understand right now there's a lot of needs for security in a lot of different ways. And you know, we're just, you know, showing you here today how to store up some power. You know, this, you know, we look at these batteries as they're just buckets of energy waiting to be expended. And this thing is actually increased. We're up at 630 watts. So it's coming into its own right. The voltage, it's popping around. Water seems to be kind of bubbly. And we're at 103.8 if you get here. And we're going to get to a point of diminishing returns from not having this thing 104 degrees. You're just going to get to a point with this thing where this is not insulated well. And I don't think bubble wrap was, I don't think bubble wrap has a great R value, but you know, it is what it is. I could have did better, but this is more about, to me today, trying to see how many watt hours we can get out of this battery. I'm trying to shoot for 1,000 or more, and we're at 300. So, if we were live right now, I'd just take these questions. The overcast isn't working with me here. We've had a lot of flooding here over the last couple weeks. You know, I tell you what, I mean, through this pandemic and everything like that, we have, you know, we've taken off, and I've made a commitment to come out here and make these videos, but, you know, it really is all hands on deck here, you know, for a lot of the time. You know, I own the company, I'm out here throwing boxes, I'm out here building stuff, I'm out here working for you guys, and I appreciate the opportunity to, you know, to have that, and to be able to get out here and do the things that we've been doing to help our customers out. I'm gonna shut the door here so we can lose some of that feedback. Yeah, so we're 26 minutes and 7 seconds in. I don't know how long this is going to take. I really don't want to turn the video off. I don't want to, you know, I don't want to bore everybody to death. I want to show you guys a couple products. If you weren't heating water, which we're heating water today, this is the virgin load resistor, and it's actually kind of big. Compared to this is one that we sold 5 years ago, and we get in and look at things and try to see how we can make them better. And you know, as we got bigger wind turbines and things started making power, and we started popping 80 amp breakers and things like that, you know, this ceramic tube heats up, and you need to mount this in a vertical orientation. If you see these holes up here, it allows the heat to escape. You see this guy right here, in comparison, I mean, I don't know. I mean, I think sometimes in the sales videos, you know, we've sold these things for really, really good prices, but we've got a lot of money invested in these guys. But I don't know if you can get a perspective. Now this is 2014. You know, this is what everybody was running in 2014. This is, you know, this is a 1,000 watt resistor, and you know, we got 300, we got 500, and 300, 500 are still bigger than this one. But if you can get a perspective on that, well, I tell you what, I'm not going to be facetious, and I'm not going to get out and compare our stuff to what other folks have on the market. But needless to say, that resistor is big. Now I hear, yeah, I'm putting the mic back on. I forgot about the mic. You run your mouth for a half hour, you kind of forget what you're doing, especially if you're Tony, right? So I hear some gurgling and bubbling going on in here. Kind of want to see what's going on. We got 107, 108. Yeah. Go ahead and set it back up. I'm going to take a peek in and try not to let too much heat out. And water's nice and warm. Yeah. I do believe I'll just let it do its thing there. We got 630 watts running through. We have not backed off of the 12.4. And away we go. I'm going to take a break for a minute and turn this off and let this keep running. And go get me a refill on my coffee, and I'll be back to talk some more about some of the things that we got going on at Hurricane Wind Power. Thank you. We're going to take an intermission, and we'll be back in 5. All right, so let's figure out where we left off. I had me a little Friday coffee accident. Everything wouldn't be complete without that. But, you know, we haven't dropped 1 volt under load. We're still over 600 watts. We got a steady 50 amps coming. At some point, that stuff's going to stop dropping down. If you count the time that we've been going, and you just look at the fact we've got a 50 amp steady load on this thing. I mean, this isn't something we're just like putting a little bit of a load on it. I mean, I think it's a pretty harsh load. We're not done yet. We're halfway there. We'll see what we end up at the end of the day. I don't know where the water's at. It was growling at me a minute ago, so we're going to do that, and then I'm going to talk about backup systems. So, okay, come check this out. So the people won't think, since you've been gone, let's see, let's get this over there. So we're at about 118 degrees. We got some steam coming out. I hope we can boil some water today. That'd be neat with no insulation around this thing. I think we're going to lose a lot of heat though, but nonetheless. Now we're here. It is what it is. So, is that thing lined up? Let's talk about a backup system. If you have a electrical line in your home right now currently, and you are worried about, say you got a backup generator, but a lot of calls that we have, people are just like, well, I mean, that's all well and good, but what happens when we run out of gas? Then what, right? So, for you guys that have the electrical line in, a lot of you don't know that there's a thing out there called an inverter charger. So if you have a 12, 24, or 48 volt battery bank, you can get an inverter charger. And if you don't even have wind or solar hooked up to it, kind of like one of the, what do you call the things that, when your computer, UPC, whatever, universal power supply, I might be wrong, but the thing that you hook your computer up to, where, if your power goes down, you lose your computer. You can kind of do the same thing with an inverter charger for the critical loads in your house. You've got a wire running in. It goes over to your inverter charger. It passes through in the inversion, it will charge a battery bank. You know a storm's coming. You know your power is going to go out. Your batteries aren't charged, even if you don't have wind and solar. You can put this inverter charger on, and to some extent, to whatever the battery capacity you have, you can put. Now, I like the Magnums. I like the Magnum 4448 PAE. I think everybody knows that you've seen some of our work, the split phase inverters. I like that Connex 6848, the Radians, some of those systems. And this is kind of how we work it. If you're going to go and back it up with some solar, with the volts times amps equals watts, if you're going to exceed about 1,000 watts, we don't want you to buy more MPPT charge controllers than you have to, because that ends up being that's a big purchase. So let's assume we had an Outback FM80 or a Midnight Classic. One of them's got 80 amp capacity. The other one has 96 amp capacity. So if you go 12 times 80, that's the end of the parade for the Outback. And, the 96 at 12 for the Midnight, you're around 800,000 wattish. Smaller solar systems, you can do that. A lot of you really need to step up to the 4024. I'm using the Magnum line, but again, on our website, we're getting some of that stuff caught up. The Victron Energy stuff, especially a lot of the Marine guys, really into that stuff. We got the Victron, Ames. A lot of you guys out there have asked for that, so we've added that. There's tons of inverter chargers out there that you can put on, put in your home and build your backup system. So if something happens, you're not without power. For the folks out there, especially that have medical supplies, CPAP machines, if you've put back meat in your deep freezers that you don't want to lose, these type of things, who would have thought that, hey, everybody, I'm okay, I've got a Generac, and, a lot of folks have thought, well, I'll always be able to get propane. I don't have to worry about these things. They do not apply to me. And, that thinking over the last 3 to 4 months has changed, which is why you don't see me out here running my mouth on YouTube all the time, because I'm spending a whole lot of time helping people put systems together. But that is one of my favorite ways of doing things. And you can get, these circuits, you can integrate those in once your critical loads are running. If you fix that to where, you can put your batteries, for me, anything past about a 50% depth of discharge rate, unless you're dealing with this guy over here, is, you're going to get to a point where the cycle life for the battery, what you're losing isn't really worth it. So, we've got the 12, 24, 48 volt systems. When you're getting up around 2 kW and you need that split phase because you need to run that well. Most important thing if you're trying to, make it out there is to be able to pull water out of the ground. So if your well's 240, you're really going to want to take a look at going with 24 volt system. I love the 12 volt system just to have as backup and do some things, but also having something that you can use your split phase inversion on and have the 24 volt out there. Frankly, when you start counting kilowatt hours, to me, the 48, when you get up to 4,000 or 5,000 watts of solar, if we wanted, if you want to do that with 12, that's 4 controllers. If you want to do that with 24, that's 2 $650 controllers. You can minimize your cost especially if you're just doing solar, by using the one controller and going up to 48 volt. It's also more efficient. And, any conversion that's made, when you're at 48 volt DC and you're converting to 110 volt AC, it's a step up of about 2.5 times. 12 volt, you have to step up, which I probably got a dislike for saying something about 12 volt system. So, let's give the 12 volt guys their due, and let's just understand that, with the 12 volt system, if the inverter blows up, I always like having one of those as a backup. When I'm talking about put in your 24, your 48 volt system, the what you got started with, maybe one of your 100 watt panel systems, don't dismantle it, because those are great to recharge batteries, get tools started, get infrastructure items going off grid if your larger system fails for some purpose. So these are a lot of the things and a lot of the strategies that we utilize. And I want to reinforce, one of the things that people don't look at, and I talk to people all the time, is just because you have that generator doesn't mean you need to run it all the time. And there's tons of people that I talk to that are out there running generators all the time. When you integrate the system that I'm talking about, you fire up the generator, you run it for an hour and a half, it passes through, it charges your batteries, and then it turns off and you save all that fuel. So, it's when you integrate that with the generator, a lot of times you can do a balancing act. You don't have to buy as many batteries. So, these are all things that when we talk about the actual loads and the system design, we break down and get into with the customers. So, that's a lot of what we've been working with people in the last 3 to 6 months. I'm going to check in. We're still clocking in over 600 watts. We've dropped 1/10 of a volt. We are halfway there with our battery. I'm going to take one temperature reading, and we're going to take a break here, I think. We are at 123 degrees. 123.8. So, water heating going along. Camera space is what it is, and I don't think you guys want to hear me talk all night. So we'll be back, and I'll have another mini topic to talk to while we are running through our battery watt hour countdown and see where we can get to with it. So until then, I will catch up with you in about another 5 and another drink of coffee. Alright, it is Tony the Hurricane again. I am checking in with you. I think we have been running this probably for over an hour. Coming in and out, hitting a few topics and things, talking points. We're at 714 watt hours. The voltage on this thing has dropped a little bit. It's fading out a little bit as that heavy amp draw that you've had on this thing for this long. You would tend to expect the temperature. Come in there and get this. We were at 134 in one spot, so we're almost at 140. So, that's stick your finger in there. What you think? Nice and warm, hot. It'd be good to take a shower in off of one battery. So we've been hitting in so many topics and segments that I've been talking about between watching hours accumulate and see how long our battery will last. 15 calls this week. I'm not going to overstate it, but it's at least 2 or 3 times a day. Someone has purchased a wind turbine from an e-commerce platform such as Amazon, AliExpress, eBay, and then they need help with something. And I just, I'm not jaded about the thing. I'm not mad at eBay. So it's the sellers that when you buy things that aren't from the United States. I mean, if you got a U.S. seller, they are to some extent, held to be accountable for the laws and advertising in the United States where they're from. If you purchase something from China, I mean, this isn't, I'm not giving legal advice here. I'm just, as a matter of common sense, I don't think the FTC is going to go knock down the door on somebody in China and say you sold an overrated wind turbine. But it is really ridiculous. I mean, I've got people that call that buy. Well, let's just start out with the 400-watt ones. When you buy something that weighs less than 20 pounds and it's plastic and it comes to your door for a couple $100 in a nice phenomenal foam crate, but it has little tiny blades on it. It's just, I've told my followers, my subscribers a ton of times, we've got a wind turbine blade calculator. The wind turbine blades are your motor. That is where your power comes from. Everybody focuses on the generator, and the generator is important, but, you can have the best generator in the world, and if you put 22-inch blades on it, you're not going to get any power. So, at the last time I looked, I saw a 12-volt, 7,000-watt wind turbine, and it goes up on a daily basis. This is a dumping U.S. market thing. I'm not getting into the world politics, but it's a cash grab thing right now. So, the best thing I can tell you, your consumers, if you've got something that does not perform as described, send it back. I really can't understand how we have, we got all these folks that they get a half an amp out of a wind turbine at 12 volts, and get 6 watts. And I expected it to do that. No, you bought a 400-watt wind turbine, and you've got something that won't charge your cell phone. And, it is beyond me at this point. 2 or 3 years ago, people used to bitch and complain about the American sellers that got into watt wars. Well, what's going on now has transcended that. It's completely ridiculous now. So, I keep on going back to volts times amps equals watts. So, if you look at an ad, I can't fathom how people can't figure this one out. But I'm just putting this out here to you. If you have something that weighs 20 pounds and it has, so let's give it the benefit of the doubt. Let's say it has 36-inch blades. None of these things, they have 36-inch blades, by the way, but let's say that it did. It has a controller with it that has 14-gauge wire with it that, comes in from the 3-phase, which if it did that, those would melt. And then once that's converted to DC, it would really melt. But, no one is using common sense. So, to everybody, let me just tell you, you get what you pay for. There isn't any shortcuts with your renewable energy systems, and there's a lot of mistakes to be made out there. So I'm not ragging on people about making mistakes. I've been doing this, on a personal level for about 15 years, and professionally, well over 10. So, the thing is simply this. If you spend your money and buy good components, and do your things wisely, the stuff will pay for itself. It'll pay back. If you don't, then you're basically taking out a few C notes, and you're catching them on fire. Now, I've been told by my camera lady, then this is not good because we're at a critical juncture here, that my battery's about to die. So I'm going to go get a backup battery, and we're going to finish this up because we need to pull that 1,000 watt hour mark on this battery, and I need to show you guys this. So I'm going to turn this off. We're going to get something, and we're going to keep filming here, and I will be back with you in a moment. Okay, I am slightly winded from this is what I carried in here. This is a generator for a 2,000 watt wind turbine. Now, that goes out of here on a truck. See? So, that's what it takes to get where you're going with your wind turbines. And that's what a 2,000 wind turbine, generator looks like. If I put this on a scale, that weighs 90 pounds. I didn't bring this in here for show. If you don't like the way I say turbine, or, if you don't like me or you don't like my company, look at these axials. I didn't bring the stator in here. We're still working with these things. There's some guys out there that build some really nice producing wind turbines out of those. And, when people get to the point where they get an education, to the point where they understand that, there's nothing free in life. And when I say there's nothing free in life, you can't get 8,000 watts out of something with 14 gauge wire. And you get through playing with toys with wind turbines, then, it is what it is. Can you see we've had the watts view displayed up. Let's go up close and let's see where we're at, because we're approaching where we need to be. We're tailing off a little bit. I'm not sure where we'll be by the time this thing gives up. We're shooting for 1,000. Go ahead and bring it up so everybody can see. It's up close. All right, well, let's take a look and see. I can see on the outside of this bucket, the outside, we're losing heat through this bubble wrap here. So we're at 126 degrees. So, if you had insulated this thing, this would be boiling by now. Go ahead and bring this over here, and let's take this off and see where the actual water is at. That was hot when it comes up. Oh, look where we're at. We're at hit 144, 145. Discharge off of one LiFePO4 battery, losing a lot of heat. So, this was an actual water heater rather than something we just threw together. That would be, we would be in 145, that's 5 gallons. So, that's pretty respectable out of a 5-gallon container with an axial flux stator core and this. And for you guys that see me, I keep on doing this thing and I haven't brought this stuff out, and I know you think maybe I'm posing with this stuff, but it takes a substantial amount of time to get this stuff to where the composites are done right, and just getting everything just so. I mean, we bought that commercial winding machine. We didn't do that just for the hell of it, so in amongst everything we're doing, you know, we're still working with it. It's not to the point where we're going to be pumping that out. I mean, especially considering the consumer market. When you guys get educated to the point with your renewable energy stuff, to where you realize you can't go to China Mart and you can't necessarily trust something with a bit.ly link on it, you know, which is not to say, I know a couple guys out there that are wind enthusiasts and they find good products that they believe in and they do that. So I'm not down on those guys, but you know, there's some other guys out there that are just promoting straight garbage and garbage in, garbage out. I spent a ton of time on the phone trying to, you know, educate people so they understand. And, you know, this lesson got taught to me 10 years ago. The telltale sign, you know, other than that, the blade diameter. You either have it or you don't. You know, your blade diameter, how many blades, the swept area, that is it in a nutshell. You either have it or you don't. And I am running out of power on my camera, so I don't want to lose our final numbers here on this battery. So I am going to go ahead and turn that off for a minute. I'll come back to you in just a little bit, save some battery, and talk a little bit more. So until then, we're at 12.1 volts. We're putting out a little under 600 watts into the water, and we're about to eclipse the 900 watt hour mark on this thing. So far, so good. We'll see where we end up with it, and I will be back with you shortly. Tony out for right now. Okay, so, you know, during this video, I've had an hour to talk about all kinds of things, but, you know, what this is really about is this battery here, and, you know, there's only so much that you can say about a battery while it's doing its thing, and I'm testing it, and I'm trying to show you guys what it should do. And I mean, yeah, I was hoping to get 1,000. We're running, it looks like we're going to get that. This thing has dipped down to 12. It's not running over 600 watts now, but I mean, it's still hanging in there. I mean, we've still got 48, 49 draw. One of the things I haven't touched on is a lot of people talk about, we've got a really good battery management system in here. And I want to get a temperature reading on that. You know, we're at 80 degrees on this. Let's get in here and show, you know, people. Apparently some people have got some problems with battery management. Let's get a good load. You know, look at the heat that we have there. And let's get a good look at the screen of where we're at, because we're getting ready to pass 1,000. And I'm going to move this back one more time. I hear some sizzling going on in here. We got steam straight up coming out of here. This is 147 to 150. I've seen it up to 155. So, you know, we're going to get to a point, you see that steam rolling out of there, so we're going to get to a point of diminishing returns with our water heating element. There's heat coming out of the side of this thing. It's 125 degrees coming out of the side. We didn't insulate it. It is what it is, but, you know, I said I'd take 1,000. I mean, this battery is built. I mean, it's still throwing down. I'm hoping for 1180. That's what the rating. That's what it's actually rated for. So, I mean, you've seen it dip. I think I've seen it dip down to 12. You know, this thing recovers nicely, and I've seen it go up to 12.2, and it varies, but I don't know where we're going to end up with this, and we had a good charge on the camera where he started. So, this thing's been running for about an hour, and we'll just intermittently check in with you, and we'll show you where this thing ends up at. So, just wanted to take and touch on the panels. If you go over to our website, we have the REC 310s and 315s, that bifurcated module in stock. That's what I like to put in the installs, but if you guys have something you want, we've got Hanwha, the Q Cells, the Canadian Solar, we got access to LG, Panasonic. I mean, pretty much anything out there, pretty much anything out there that you could think of, we have access to that. So, just wanted to throw that out there. If you got a specific module in mind that you need, that's out there. But, today it's all about this battery. And so far, this thing's checking out good. There's your 1,000 watt hours. That was my goal. And I'm going to turn this thing off, throw a little juice on the camera, and come back and see where we end up. I'll catch you in just a little bit. Okay, we're checking in with you. We're down to 12 volts. We're tailing off just a little bit with the wattage. The current's 48, but the watt hours out of this battery, we're looking for 1180, and I think we have a contender possibly. We'll see where we end up. 5 gallons of water we got here, and I'm at 160 degrees on this, 155, 160. You get to the point of diminishing returns, like I said. You want to show the people so they know I'm not lying to them. This is what we did out of one Hurricane LiFePO4 battery discharging into a non-insulated thing that we just kind of threw together here today. I think we have a contender on the market. 5,000 cycles is what this thing is rated at. It takes a long time to sit around with these things to test them, know what you're actually selling. And I told you guys last time I was on YouTube that we would have these things up for sale, but I mean we've ran the cycles on these things and made sure we knew what we were doing with our lithium program before we just started throwing batteries up on the market for sale. A lot of people just grab stuff and go with whatever the advertisement says and they say, come buy me now. Here we are, 83 degrees on our BMS. We've been pulling 45 to 50 amps for an hour and a half. Terminals are a little hot because I wanted to be able to jerk that off. I didn't put good lugs on there. So, I mean, we really, in terms of the watt hours, just through that heat, I've lost some energy through the way I decided to connect it. And I mean, that's on me. But, I said before, you'll see this battery soon. It's Friday. By the time I have time to write this up and put it out there, there is a new contender on the market. I'm pleased to say this was our prototype. You can see around here we've got an updated casing that's a little sexier. And as we always do at Hurricane, we'll make product improvements as we see ways to do that. But, this thing's tailing off a little bit. You see the 11.9. We're at 1145. We're down to 571 watts. But, I mean, I think it's a pretty good foregone conclusion. I think we're going to hit the 1180. And we'll save, there isn't much more to say about that, except I think price point wise, we're going to be able to not only, you can put these batteries in series, but I think we're going to be able to not only outperform the big guys with our battery, but I think the price point, you're going to be able to save several $100s with your Hurricane LiFePO4 100 amp hour batteries. So all the things we got going on, I've probably taken several hundred hours, messing with this, because I've dealt with off-grid enough to where I know battery storage is the key, not going into it like I said, you start out, looking at windmills and solar panels and inverters and things like that, but once you really get into it, being able to store that power and be able to call on it when you need it, that is security. That is, being able to take that much energy somewhere and carry it off in 35 pounds. That will get you, that's enough energy capacity and storage to get you through the night in a lot of situations. I don't know what else to say about it. We're 18 hours off the rating. We've barely dipped below 12 volts, and we're gonna go ahead and turn this off. We'll come back to you when we hit 1180. We've got water condensing. Come check this out. Come check this out. On our stator core here, we've got water condensing. We've got steam coming up through our little midnight box here. So I will catch you in a few minutes. We're going to see what this guy does. See how far we can go, and I will be back with you shortly. Okay, we're back. We were 1180 is what this is rated for. As you can see, our watt numbers, our batteries started since I was talking to you last. We were up at a little higher amp level. The voltage is coming on down, so this thing will probably trail on down pretty quick. I think we're going to eclipse 1250, something like that. I've got some dinner reservations, but we have you can buy this from Off-Grid Freddy. You can buy your lithium battery wherever you want to. This is just somewhere else. We can get a good deal on your batteries. I think we've got a superior battery in every way. I'm going to go ahead and give you some final number. So now we're down to 10.5. The BMS on this thing will cut out here shortly, but let's go ahead and get some finer temperature readings to show the load. And come on in here so everybody can see the steam from the water. So, here we go. We got the steam. We're at 100 and we're still at 160 degrees. No, 150, 160. There's no insulation on this thing. So, as far as our watt hours go, we could have done better if we put the right terminals on this thing. Again, we're in a building, we're in the testing phases. I want to be able to rip that off there if I needed to for safety purposes. The final test on our BMS, 85.2 degrees. We have no heating up here. 1208 watt hours. This thing is trailing off pretty quick. That's the end of it. But 1180 is what you're supposed to get. This thing wasn't quite topped off when we started, but 1180. I keep saying 1280. 1180 is the watt hours that we're supposed to get out of this thing. We're now down to 9. There we go. And the BMS is cut out on the unit, and we've got 30 amp hours more than 30 more watt hours more than advertised, you know, even with the port hookup. I think we could get 1,300 out of this, but 1180, I'll put it up against, you know, just like our wind turbines, I would put this up against any battery. We're gonna release this product, and I think we're going to put this thing at $6.99 for the first 30 days, introductory price to get that thing out there and get this thing in the off-grid community and let you guys see, you know, what we can do with our quality. Talked about a lot of things today, kind of went all over the place, so we had a long time to talk with you today. I hope that if you have off-grid power needs, I've talked about security needs, you know, with power, one of many things you need. Obviously, you need to protect yourself in other ways first, but when you get down to power, I'm a pretty good person to talk to. If you can't get us by the phone, you know, Hurricane Wind Power, Tony at hurricanewindpower.com, my Yahoo email. We've got a feature on our website that's interactive if we're there, you know, and you can catch me, chat with me there, message me, and whatever. I think that we can help you get where you would need to be off grid. And, you know, like I said, we do off grid, on grid, we do everything, but, you know, Hurricane, lithium phosphate battery, doing what it's supposed to do. That's the main purpose today, and happy to bring a new product to the market for you. Till next time, Tony, I'm out of here. We will get to some of these axial flux things here in the next 2 to 3 months, I believe. After that, got a lot of things. We're going to discharge that battery through one of these, hopefully next week if I have time. So we'll show you that we can handle the continuous discharge on our high quality relay in the heatsink. So, till next time, it's Friday afternoon. You guys have a good weekend, stay safe, and I will catch you till next time. Bye.